Welcome to Mr. Garofalo's podcast. In today's episode, we're going to be completing the notes packet from class, starting at example 7. At the end of class, we were discussing something called the complement of a set. As a review, the definition of a complement of a set is the set of all elements that belong to the universal set but are not in set A. There's some symbols for this, just as there's been symbols for the other work that we were doing today. The most common symbol is an A with a bar written above it, but there are some alternate ones, and you see them here to the right. I don't think we're going to see these ones too often. This will be the more common one that we would see, or we could even see the actual word complement written. So if you look at example 7, they ask you to use example 6 and find, this would mean the complement of set A. So that's really asking us to find all the numbers that are in the universal set but not in set A. So let's go back up to that example. So here's our universal set, 1, 2, 3, 4, 5, 6, 7, 8, 9. And set A has 2, 4, 6, and 8. So as I look at my universal set, I'm going to go ahead and cross off 2, 4, 6, and 8 because those numbers are in set A. Remember, the complement is asking us what numbers are not in set A. Well, the numbers that we have left would represent the complement. 1, 3, 5, 7, and 9. So the complement of A would be equal to 1, 3, 5, 7, and 9. Okay? On the next page, you'll find another example asking you about the complement of a set. In this case, they're giving us U equals. Now, remember, U equals universal set. That is the only numbers that you're going to consider for this example. They happen to be the one-digit natural numbers, but also 10. And they give us R as 2, 4, 6, 8, and 10. And they ask us what elements make up R with this bar over it. And that would mean the complement of set R. So as I look at my universal set, I'm going to take out any element that I see is already in set R. 2, 4, 6, 8, and 10. Anything that remains would be the complement. 1, 3, 5, 7, and 9. So the answer is very similar to the last problem. You would write R with that bar over it to represent the complement of R, 1, 5, 1, 3, 5, 7, and 9. That would be the answer to example 8. For example 9, we have a lot of questions being asked of us. Well, they give us 3 sets in the beginning. The first is U equals. Remember, that's the universal set. So we're only considering, it looks as though we're only considering the multiples of 10 up to 60. That would be 10, 20, 30, 40, and 50, and 60. Set A only has one element, just 10, and set B has 3 elements, 10, 40, and 60. They want us to write the following. Okay, so this is sort of a culmination of everything we did today in class. This first one, this symbol here means intersection. And that would be the elements that A and B have in common. In other words, elements that belong to both A and B. As I look at A and B, they both have 10. So the intersection of A and B is just the element 10, because it's the only element they have in common. In fact, it's the only element that A even has. So if A didn't have 10, had a different number, say 30, then we would have a null set as our answer, because they'd have nothing in common. Now part B, this is one of the symbols for complement. Complement. This is asking us for the complement of our answer for part A, the complement of the intersection of A and B. Well, the intersection of A and B was 10. So I'm going to take out 10 from the universe. Well, everything that's left is the complement. Remember, it's all those elements that are left over when you take out the elements of the set you're working with. This time we're working with the intersection of 2 sets, and that intersection was just 10. So the complement of the intersection of A and B would be 20, 30, 40, 50, 60. Move down to part C. This is the symbol for union. When we're working with the union of sets, we're bringing together all elements of each set into one single set. They don't have to belong to both at the same time. They just need to belong to one or the other. So as I look at sets A and B, I see they both have 10, so that's going to be in my union. And then set B also has 40 and 60. So the answer to C is actually the same as what's already in B, but that's only because A only had 10 as its only element. If, let's say, A also had 30, let's just suppose A had 30, then the union would be 10, 30, 40, 60. We would include the 30 in our answer here. Part D is asking again for the complement. But this time it wants the complement of the union of sets A and B. In other words, it wants the complement of these numbers here that we just did. So as you look at the back at the top, again, I like to do this by crossing them off. So I see I have 10 already, I have 40 in this set, and I have 60. So the union of set A and B has 10, 40, and 60. The complement would be whatever's left, 20, 30, and 50. 20, 30, 50. So the answer to this one would be 20, 30, 50. And the last question goes back to what we learned early in class, which was subsets. This question is asking, is set A a subset of B? In other words, is set A a smaller group of B? So let's take a look. Well, B has 10, 40, here's B, 10, 40, and 60, and A has 10 as its only element. So yes, since 10 is an element of B, and A only has 10 as its only element, then yes, the answer to this is A is indeed a smaller group of set B. Yes, since 10 is an element of set B. I hope you found this helpful. If you want to watch this video a second time, it might be helpful as you go through the problems on page 73 in your textbook. I will see you in class tomorrow.